So good morning, everyone. So once again, welcome to Physics by Physics. And in this C.T.P series, we will take some more problem based on divergence property and curl property. And we will mainly see on the flux related question and based on the Gauss law. So let's see our QIP sheet, that because I'm taking problems from our QIP sheet. So in last lecture, I have shown you all the questions. So you have to try all these questions. I have also given you the answer also. Now let's take some more questions. So let us solve this question. Question number 9. Again, it's asked in IIT-JAM 2010. So it's for practice, because we have combined all the exams, whether it is IIT-JAM, NET, JEST, GATE, any exam, CUET, for all the questions related with flux. So it's for calculation. Don't see the exam, whether it is JAM or NET, because you have to clear your concepts through problems. So focus is on question, not in exam, because if you know the concept, you can easily solve this problem, whether it is asked in NET, GATE or IIT-JAM or JEST and TIFR. So focus on the concept. So just see this question. A closed Gaussian surface consisting of a hemisphere. So it's a hemisphere, and then a circular disk of radius r is placed in a uniform electric field. Field is uniform, as shown in this figure. This circular disk makes an angle theta with the angle theta 30 degree with the vertical. Now you have to find flux of the electric field vector coming out of the curved surface. Just see what will be the flux coming out of the curved surface. So flux is what? Number of field lines. So in this situation, you can see whatever be the field line that will pass through this circular disk, that will come out through the hemisphere. So instead of calculating through hemisphere, because if you calculate through hemisphere, you will get the answer, but calculation will be lengthy. Then you have to use spherical polar symmetry. But what we will do, we will calculate the flux through this circular region. Because field is uniform, area is fixed, just you have to see angle between E and area element. So let's see how I will solve this question. So answer 9. So let's see. This is and its radius is the circular disk of radius r. So this is the center of the disk, and this radius is r. And field is given like this. This is the electric field in this region. Electric field is uniform, and this angle is given as 30 degree. So just see what will be n cap. So you have to draw, area element will be perpendicular to the surface. So this will be the n cap direction. N cap is area element over the circular disk. This is the circular disk. So radius is given. If you draw the circular disk, it looks like this. So you have to see flux that will cross through this surface. So if this angle is 30 degree, let's extend this. This is 30, this is 90 degree. So what will be this angle? Can you find this angle? because you have this line and this makes an angle 30 degree. So this will be also 30 degree. So angle between electric field and area element is 30 degree. So what will be electric flux? This is given by E dot dA. This will be E dot dA. E dot dA. So E and dA angle is 30 degree. So this will be given by magnitude of E dA, because area is fixed. So this is pi r square and angle is cos of 30 degree. This is cos of 30 degree. So what will be cos of 30 degree? This is under root 3 by 2 pi r square into E. So this will be the flux. So option B is correct. So in this case, option B is correct. So it's a question based on electric flux. So instead of calculating over the hemispherical surface, if you try to calculate over the hemispherical surface, you will get same answer, but calculation will be lengthy. So use this concept that number of field lines will be same, and that you can easily find. E dot dA over this region you can easily find. Clear? Chalo. Now let's see question number 10. Just try to solve question number 10. Take 2 minutes and try to solve. Question number 10. अब देखो, now the total charge contained within the cube in which the electric field is given, where epsilon naught is the permittivity of free space. What is the total charge contained if electric field is given? So what will be total charge contained? Q enclosed is Gauss law, epsilon naught closed E dot d. So if you want to find directly, then you have to do E dot dA on all 6 surfaces. So we know from the fundamental theorem of divergence, whenever you have to find closed surface integral, you can convert this into volume integral. That will simplify your calculation. So always you have to see how you can simplify your calculation. So if you use the divergence theorem, this will be given by divergence of E d tau. Divergence of E d tau. D tau is volume element. Now see, what will be divergence of E for this vector? E is given by K times 4x square I cap plus 3y j cap. So what will be divergence of E? This will be simply del Ex x component plus del Ey del y component. So because this is x cap component, here unit vector is I cap j cap. So this will be what? 8kx, and this will give you plus 3k. This is divergence of E. Yes or no? So now Q enclosed is given by Q enclosed is given by epsilon naught. I'm taking K common here. K is common. Volume integral is triple integral. So this is 8x plus 3. And what is d tau in Cartesian coordinate? Dx, dy, dz. X varies from 0 to 1. Y varies from 0 to 1. And Z varies from 0 to 1. Now just calculate this value. So if you integrate with respect to x, what you will get? 8x square by 2 plus 3x 0 to 1, and dy dz will give you 1. Yes or no? So what will be this value? This value is k epsilon naught. This is 4 plus 3. So that is 7k epsilon naught. So answer is 7k epsilon naught. So option A is correct. So just see, you don't have to calculate E dot dA. Otherwise, you have to find E dot dA 6 times. So whenever you can apply divergence theorem or Stokes theorem, you have to always see which side will give you the simplified calculation. Accordingly, you can simplify your calculation. Is it correct? Okay. Now see next question. See question number 12. Let's solve question number 12. Try to solve question number 12. Solve it. Solve question number 12. Now see, the charge density as a function of radial distance r is given. And it is given that charge density is this value for r less than r and 0 otherwise. For r greater than r, charge density will be 0. Now, the electric flux over the surface of an ellipsoid with axis 3r, 4r, 5r center at the origin. Now, it's an ellipsoid. So, there's ellipsoid with axis 3r, 4r and 5r centered at the origin. So what you have to do, because although this radius is given along this axis side is given as 3r, 4r and 5r, but charge is distributed from 0 to r only. So when you integrate, you have to integrate 0 to r only, because outside charge will be 0. So in question number 12, so what will be flux? Flux is, electric flux is given by closed E dot D. It's a closed surface. So this will be the electric flux. Okay? Now this will be given by 1 by epsilon naught Q enclosed. And Q enclosed is given by volume integral rho d tau. But now we will use spherical symmetry, because charge is distributed in a sphere of radius r. Although this, it is given that ellipsoid, but charge is distributed in a spherical region. So flux is given by 1 by epsilon naught. I will write here rho. So rho is, this is rho naught r square minus r square by r square, and d tau will be given by what? R square sine theta dr d theta. Clear? Now you should calculate it. 4 pi rho naught epsilon naught r square, and this will give you r power 5 by 3 minus r power 5 by 5, and this will give you 4 pi rho naught by epsilon naught r square. Here you will get what? 5 r power 5 minus 2 minus 3 r power 5 by 15. This will be the value. So what you will get, this value is, this will be 2 r power 5 and 15. So this is 8 by 15. This will give you 8 by 15 epsilon naught pi rho naught, and because r square, this will give you r cube. 8 by 15 epsilon naught pi rho naught r cube. So option C is correct. So here option C is correct. So in this way you can solve the question. So you need to learn the concept, which formula you have to apply, then how you will simplify your calculation, and what is the trick given in that question, and then it's a matter of calculation. So if you follow these steps, only then you will be able to solve question within a limited time period. Clear? Chalo, note it down. ठीक. Let's see other question. Now let's see one question based on the electric field using Gauss law. So it is given that a solid sphere of radius r, it's a solid sphere of radius r, has a charge density rho r. It is given as a function of r, where rho naught a and r are positive constant. And it is given that the magnitude of the electric field at r by 2 is 1.25 times that r is equal to r. What is the value of a? So how we will calculate? So because there is a spherical symmetry, so we will use the Gauss law. You know that whenever, although Gauss law is valid for all surface, whether it is symmetrical or unsymmetrical, but it is useful for symmetrical surfaces only. So whenever symmetrical charge distribution is given and you have to find electric field, we have to use integral form. When electric field is given and you have to find charge density, then you have to use differential form. But when you have to find charge enclosed, then you can use the directly integral form. So you have to remember this trick related with Gauss law and electric flux. So now we will see question number 16. So now what will be the electric field as a function of r? Magnetic field at a distance r is equal to r by 2 is 1.25 at r is equal to r. So we will find the electric field inside. So consider it's a dielectric sphere. Dielectric sphere, radius is r, and its charge density is rho. This rho as a function of r is given. So it's a non-uniformly charged dielectric. Whenever charge density is given, that is dielectric. So you have to see in question whether it is dielectric or conductor. Normally in electrostatics, material will be either dielectric or insulator or conductor. And you know that when conductor is given, charge density will be 0. But here charge density is given. So it's a dielectric. Now you have to see what will be electric field at any point P inside. So what you have to do, let's draw a Gaussian surface. This is a Gaussian surface of radius small r. And then we will apply Gauss law for this Gaussian surface. So we know that closed E dot dA is 1 by epsilon naught Q enclosed. And because charge density is function of R only, so when you calculate d tau, you have to integrate with respect to R only. So we will write d tau as 4 pi R square dr, because you can absorb sin theta 0 to sin theta d theta 0 to pi and d phi 2 pi. So that will give you 4 pi. So this will give you, at this point, magnitude of field is mod E. So in spherical symmetry, you can write this as mod E into 4 pi R square. And this is 1 by epsilon naught. And I'm writing here rho 1 minus AR by R. And d tau is 4 pi R square dr. And this will be, let's say, 0 to small r, because you have to find charge enclosed within the Gaussian surface. Right hand side is what? In Gauss law, this will give you charge enclosed within the Gaussian surface. But this electric field is field due to all charges. So you must remember this point. When you are applying the Gauss law, if you are seeing this equation, E is field due to all charges. But this charge enclosed is field within the Gaussian surface. So that will give you the electric field. So now we will write this as mod E into 4 pi r square. I am taking 4 pi common, rho naught common by epsilon naught. Now, if you multiply with r square, what you will get? This integral is r cube by 3 minus a by r. This is r cube. So that will give you r power 4 by 4. Limit is 0 to r. Yes or no? So now this will be given by 4 pi. So this is simply same value. If you put 0 to r, so that value will be same. So you should write this as, because we have integrated 0 to r only. Now what will happen? This 4 pi will cancel out, and let's divide this by r square. So what will be magnitude of the electric field? Magnitude of the electric field is rho naught by epsilon naught. This will give you what? R by 3 minus AR square by 4R. 4 capital R. AR square by 4 capital R. Now use this condition. Electric field at R by 2 is, since magnitude of electric field at R is equal to R by 2 is 1.25 magnitude of the electric field at R is equal to R. So let's use this result, and you should write here at R by 2. So this will give you rho naught by epsilon naught. This is R by 2 by 3 minus, this will give you A R square by 4 by 4R. And this value will be 1.25 rho naught by epsilon naught. Put R is equal to R. So this is R by 3 minus AR square by 4R. Now you have to solve this. Let's see what value you will get. So now rho naught by epsilon naught will cancel out. R will also cancel out. So this will give you 1 by 6 minus A by 16. And this will be 1.25 is what? 5 by 4. And 1 by 3 minus A by 4. Now let's calculate it. A by 4. So this value will give you 1 by 6 minus A by 16, 5 by 12 minus 5A by 16. So this will give you 5A by 16 minus A by 16, 5 by 12 minus 1 by 6. I am writing 2 by 12. So you will get 4A by 16 is equal to 3 by 12. Or this will give you A by 4 is 1 by 4, or A is 1 here. So it's a matter of calculation. If you know how to find the electric field in spherical symmetry using Gauss law, then from the given condition, you can just check the value. So option B is correct. So here option B is correct. Let's check it. Note it down. You have to solve other questions. I will give you some more questions. Let's take this particular question. Yes. Let's solve question number 90. Now see, let's first solve this 20 and then solve question number 19. It's a tricky question because solve question number 20. Try karo. Try to solve 20 and 19. First solve 20 and then 90. Then I will discuss. Take 2 minutes and try to calculate. Try to calculate it. So it's all about the concepts. So reason of compiling these questions of different exam is so that you can solve more number of questions on a one particular concept, and that will strengthen your concepts. So once your concept is clear, you remember the formula, you know how to calculate it, you can easily solve problems. So it's about conceptual clarity, learning problem solving techniques, and then you have to also avoid the silly mistakes. And then you will see you will build speed and accuracy. You have to build your speed and accuracy also, so that within limited time period you can solve the maximum number of questions. Okay, chalo. Now two spheres of radius r carrying uniform charge density plus rho and minus rho respectively are placed so that they partially overlap. Call the vector from positive center to the negative center by this vector d. The electric field in the region of overlap. What will be the electric field in the region of overlap? Just see. So in this case, they are the uniform charge density. So one is, this is the one, and this is the second one. And they have, and this is the region of overlap. This is the region of overlap. So this contains positive charge density, and this is minus charge density, and this vector is given as, this vector is d vector. Let's call this as center O1 and this is center O2. And you have to see what will be electric field at any point P in the region of overlap. So let's call this vector is R plus and call this vector as R minus. Means you have a, this is O1, this point is O2, this is D vector, this is point P. So this vector is R plus because this is r distance away from the center of positive charge. So I am taking this symbol, and this will be r minus. So what will be the electric field in the region of overlap? So you have to use superposition principle. You have to find field due to individual sphere, and then you have to take vector sum. So you have to remember the standard result. What is the field due to uniformly charged dielectric sphere? That is the standard result. So you should remember. At least you have to remember the standard result and the formulas. So now we know what is the field due to uniformly charged dielectric sphere. Field due to uniformly charged dielectric sphere, and that is inside. If you have a dielectric sphere having charge density rho at any point P, this vector is R vector. What will be the electric field? So this is given by, electric field is given by rho R by 3 epsilon naught R cap. Or this is given as rho vector R by 3 epsilon naught. So if you remember this result, only then you can find. Otherwise, you have to derive first what is the field due to uniformly charged dielectric sphere. So it's a standard result. You must remember it. Now see what will be. Now focus on this plus rho charge. So point P is within this. So what will be the electric field at point P due to plus rho charge? So this is what? This is the center O. So from the center O to any point P, you have to use this relation. So this will be given by what? Rho R plus by 3 epsilon naught. Okay? Now, what will be E minus rho? Means now R from the center of the minus rho charge, this is distributed uniformly at R distance. So you have to take minus sign because charge is negative. This is for positive charge density. If charge is negative, so I will write here minus rho R minus by 3 epsilon naught from the center to point P. Position vector is R minus. Minus sign because charge is negative. So resultant field E is given by superposition, vector sum of these two fields. Vector sum of these two fields. And this is rho by 3 epsilon naught R plus minus R minus. Now you just see what is the vector sum. Vector sum is given by R D plus, let's see, D plus R minus is R plus. So vector D is given by what? R plus R minus. Okay? So you will get, this will be, so E is given by rho D vector by 3 epsilon naught. Okay? I have also compiled what are the different types of problem that is given in Griffith book that is relevant to your exam. I have also compiled those questions. So this is the question based on the Griffith book. So this will include previous year questions on particular topic and also question from the standard book. and that is relevant for your exam. Clear? So just see, electric field is rho d by 3 epsilon naught. So option C is correct. Now solve question number 19. Same type of trick you have to use. Solve question number 19. Try to solve. Try to solve question number 19. Okay? So this is the last question from today's C.T.P series. Question number 19. So in this case, consider a sphere S1 of radius R which carries a uniform charge density rho. Now this contains a uniform charge density rho. A smaller sphere S2 of radius less than R by 2 is cut out and removed from it. So there is a cavity inside it. The center of the two spheres are separated by the vector B. Vector B is given n cap R as shown in figure. The electric field at point P inside S2. What will be the electric field inside S2? So just see, you have a bigger sphere of charge density rho. And there is a cavity inside. Let's make a cavity inside. There is a cavity inside. So means this charge density is rho and its radius is R. This will be its center. This is its center. And it is given that this is vector B. This vector B is given. Now take it as O1 and this is at O2. So you have to find what will be electric field at this point P. So if this vector is given as R, this vector is R. But you have to write answer either in terms of R or in terms of N. Now see, there is a cavity and this cavity is unsymmetrically placed. If cavity is placed symmetrically about the origin, then because of the symmetry, you can use the Gauss law, and in spherical symmetry, you can find the electric field. But here, but in this case, because it is unsymmetrically placed, so what we will do, you have to assume that you have embedded another dielectric sphere of charge density minus rho. हमने ये assume कर लिया. Let's assume you have embedded a charge density of minus rho so that this plus rho and minus rho will neutralize. And you have cavity-like situation. Now you have a cavity-like situation. So you have to use this trick. Whenever you have unsymmetrically placed cavity, you should just put the, if this charge density is positive, put the another sphere of charge density negative. So you have a cavity-like situation. Now you can apply the superposition. So you have to find field due to plus rho, field due to minus rho. And I am taking this, let's say this vector is R minus. So again, we will use the electric field due to uniformly charged dielectric sphere. You know this formula I have written, rho r by 3 epsilon naught, because it's a uniformly charged. So I'm going to use this relation. So what will be electric field at point P due to plus rho? E plus rho is given by same rho r by 3 epsilon naught. This one. And what will be field due to minus rho? So this is given by minus rho r minus by 3 epsilon naught. Now you can use the superposition principle. Okay? So resultant field E is given by E plus rho plus E minus rho. So this will give you rho by 3 epsilon naught r minus r naught. Now see, what will be B plus r minus? If you take the vector sum, this will be vector r. So B is given by r minus r vector minus r minus vector. So this can be written as B. So this is rho B by 3 epsilon naught. And B vector is given as r by 2. So this is rho r by 6 epsilon naught n cap. If you put B is equal to n cap r by 2. So B is n cap r by 2. So this is rho r by 6 epsilon naught. So just the option C is correct. So option C is correct. So I have taken some question based on electric flux and some based on the Gauss law and superposition principle. Is it clear? So that's all from today's lecture. Now in next session, we will take electrostatic potential and other topics. I will also take then electronics, mathematical, other topics we will take. So in next lecture, we will focus on potential. Clear? Okay. Thank you, everyone. Thank you.